We became involved with this project after we had finished the STAR off-grid school, which is actually across the street from this location. What we have here is a completely off-grid, three-phase, 480 volt solar power system, and its main purpose is to provide power for the deep well pump that's located in the building behind us. That's a 40 horsepower pump that's set at about 1,200 feet. It's a pretty important pump, pretty important location. That provides drinking water for a lot of residents in the neighboring area. It's one of the few quality water wells.
We decided to start a solar-powered off-grid school because my family and I had lived for years off-grid and solar-powered out here on a ranch. And when we started the school, it was important to use the expertise that is necessary as the technology got more and more sophisticated. And I have to say that Done Right Electrical, with our work at the STAR School, has proven themselves that they know very well what they're doing. And for this second project, which was considerably more complicated at the community well, this whole area is dominated by homes that are off-grid, and that means not only do they not have utility lines of power coming to their homes, but there are no water lines coming to homes out here. So the community well is a lifeline for the entire community.
Once we got on site, the first part of the installation was to lay out the ground for both the equipment pad that we're on here talking to you today, and also to lay out the array pad where all the solar panels are. And once that was laid out, the next step would to have been driven all the ground screws, which are the anchors for the solar panel array out there in that field. And then we installed the uprights and the racking and the solar panels themselves. Once that was completed, we moved on to construction of this equipment pad that we're standing on here today, installing all the underground conduits, which were pretty extensive. This has a lot of underground conduits, both that feed all the equipment within the equipment pad itself, and then feed outlying buildings and generator inputs that this feeds and is fed by. And once that was all done, concrete was poured, and then all of this stuff that you see behind us was bolted down to the concrete pad and assembled and wired and terminated and tested.
This project was several years in the making, actually. I've worked in this area for quite a long time, and to bring this project together finally and see it come together was like 2 years worth of work. It was amazing to see it all come together, it working, it doing what we designed it to do, providing water and a place for the community to get together and to support the culture out here.
And as far as like a light commercial project goes, this is pretty sizable. I mean, we have two really robust 480 volt native inverters, two really large Discover batteries behind us. So in that sense, it's pretty big for like a light commercial project.
It is a little intimidating working with 480 volt three phase, but these large Discover batteries that we've got are just a really large version of our Helios battery. You got the 60K SolArk, you got the AC in, AC out, the DC cables and the COM cables. Basically runs over to our AES 210. So it's just a larger version of a smaller system made for commercial applications.
Effectively, this is like a utility scale cabinet solution. Paired up with hybrid inverters like SolArk and Solis, it's often at a lower voltage. So we've got this particular application, for example, is 210 kilowatt hours per cabinet. So there's 418 kilowatt hours usable capacity here between the two. And then it's attached to the 260K SolArks to provide 120 kilowatts total. And then there's a solar array as well, for generation, PV generation, energy, and then the generator to support any supplement that's needed.
When we got here, the generator that we were using was already 20-some years old. It was breaking down every once in a while, and we just had to keep cobbling it together and get it going because of two things. One, the age of the generator and the lack of reliability in the long run, and our desire to follow our initial philosophy, which is to be self-sustaining.
I think there's two things that separate NAZ from other vendors that you could maybe deal with. And the first is they're experts in the field. If you need help designing or sourcing the right parts, they're there for you. And the other thing is everybody there has just always been pleasant to deal with and knowledgeable and helpful. You're in the middle of a project like this, especially when you're understaffed, you've got 100 details a day that you're trying to deal with, and knowing that you can call somebody and say, hey, this is what I need. Yep, we'll handle it. And you know it's handled. You don't have to babysit or come back or revisit it.
Well, I am very excited about the future with this property. It not only includes the main source of water for the entire community, but it also allowed us, through some federal grants that we received earlier, to upgrade the main building and create what we're calling a makerspace, which is a place where people can come from the community and from the school and learn various technologies. The solar technology is here that allows us to do things that 20 years ago we couldn't dream of doing. Other communities may think this is just not feasible, and we're here to demonstrate not only is it feasible, but it makes a lot of sense.